Hello guys, so this is the fifth tutorial of our TensorFlow series, and in this tutorial we are going to explore two very important APIs. First one is the split API that's available part of your TensorFlow dataset module and load method in particular, and the second one is your TF records, which is the backbone of your TFDS. That means TensorFlow dataset, right? So let's start. The first thing is, while you will be loading the data, right? So for every uh, tutorial so far we have used MNIST dataset, right? So for MNIST dataset, it is already well known, well equipped and well structured data, right? But it will not be the case every time when you will be doing some tutorial or your uh, office project, right? So you will be having your own custom data set that probably you will bring to TensorFlow for machine learning from, let's say, some data source, Excel or Snowflake, Databricks or whatever. So the fastest way of working with that data inside a model will be your TFDS, provided you complies with all the requirement of TFDS. Okay, so we are here showing the capability of split API that's TFDS provides. So if you can search split in TFDS, you will see the API and all the available possibilities. Okay, so this is, as you can see, tfds.split. These are the different parameters or options available. So we are not going to uh, detail about all of this, right? We'll be only specifying some of this requirement and some of the very real world use cases. So first thing is specifying which type of data set you want to load, whether you want to load a training data set or testing data set, that one. So for that, this is the code. Okay, so first you just load this TensorFlow and TensorFlow dataset. Okay, and once TFDS is in your workspace, so tfds.load is the method from which you can load any dataset that's available as part of your TFDS. Now let's say we are loading this MNIST dataset, and in split we have mentioned that we want the train split as well as test split. Okay, so as we have mentioned two splits here, so the results will be two tf dot data dot dataset instances, right? So that's why we have given train ds and test ds, these two objects in the left. So once, let's say, these are loaded, and I think this is already loaded and available in our cache. So if it is not there, what you can do, no, you can just disconnect from here and again reconnect. You will see the data set will get downloaded and loaded, will get loaded here. Okay, so once the data is loaded, you can see the data set. So as you know that your training data set of MNIST has 60,000 and test, I guess, have 10,000 data, right? So same thing we will print here first. So let's just wait for this execution to get completed. So as you can see, 60,000 for training and 10,000 for testing data set, right? Now what if you don't require this training and test data individually, and you require the data as a combined data, right? So you can specify this by only specifying a plus concatenation sign or plus symbol. So train plus test, if you mention in your split, it will understand, okay, you are asking for the complete data set, and this API split will work in that fashion. It will combine the whole data and it will provide you the whole data. So this chunk of code will return you 70,000. So 60,000 plus 10,000 will return you 70,000 data. So this is the power of your TensorFlow dataset, right? So same method we are calling, only changing little bit of notation in the split API, and you can see we can manipulate the whole dataset the way we just want it. Okay. So now let's say we are going to do some sort of sampling, right? So part of sampling, we require the first 10,000 rows for doing some, let's say, EDA on top of the data. So how we can choose the data, the 10,000 data from our training data set, that is also pretty much simple. So in the split, we just have to mention the first 10,000 indexes that we required. Okay, and this is pretty straightforward, like we used to mention in Python list operations. So if you mention that, you will have your data set with 10,000 rows. Okay, so same loading example, same method, only changing the parameter that we are passing in split API. So that's why this split API is much more important. So let's say now instead of 10,000 I want 20,000. We'll just change it 20,000, change the name of here as 20,000, and if you print the length, you will find that okay, 20,000 data got loaded. And now with this data set I can do whatever I want. Okay, and the data will be loaded in TFDS, so it will be much more faster than your traditional data loading. Now let's say I wanted to load the data from 20,000 data from backside of the training dataset. That is also we can done by using same list method, right? So from backside I want 20,000 data. So the minus indexing how it works in let's mention it as backside, right? So B. So this indexing approach will provide you the same 20,000 data, but from backside, from tail side. Now let's say your requirement has to deal with not absolute number of datas or rows, but the percentage of data. That also can be done using same split API. You just have to mention the percentage. So instead of rows, number of rows, absolute values, you mention the percent and it will be done automatically. And same thing as well as from the backside as well. So same thing, let's say on backside, let me don't change the object name as we are not going to use. You'll see now this time we'll have 12,000 records from backside of the training data set. Now for k-fold validation, for most of the machine learning cases we require a k-fold validation, cross validation thing. That thing also can be done using same line of code, same method call, only changing the parameter. Basically it is not prompt, it's a parameter little bit differently. Okay, so here if you can see, this is our validation data set. So our validation data set comes with tfds.load function. Definitely we are loading MNIST data set, and in the split we are mentioning that okay, I want the training data from this placeholder percent to placeholder percent. Okay, and in these two placeholders we are doing a dynamic value imputation, right? And the format is k to k plus 20 I want. Okay, and for k in range 0 to 100 with 20 interval. So for the first value of k equals to 0, what will happen? The format will become inside format it will become 0 and 20, right? So my training data will be from 0th percentage to 20th percentage, and whatever left, right, that means before 0 percentage and after 20 percentage, everything will fall in our trained data set. based on the split percentage we have mentioned, right? So if you can see here, so before 0% means nothing, and after 20% means from 20% to 100%, whatever is remaining will be in our training data set. So again, when my k will be 1, then from let's say not k will be 1, okay, next k will be 20. So for 20 to 40, my training data will be from 20% to 40%, and in that case my training data set will be everything before 20% of data, everything after 40% of data, right? So that's how your k-fold validation data set you can construct using TFDS and with just a single line of code, right? So this is the power you have to understand, right? And you have to utilize when you will be building huge machine learning modules, and you will be doing the testing and all, right? So if you run, it will load 5 datasets for validation and 5 datasets for training based on the configuration we have provided here, right? You can see, and you can also compose let's say part of data from training and part of data from testing, or basically different chunks, and you can create a composed a combined data set for your testing purpose as well, right? So here, as you can see, we are taking 10% data from testing and uh, 80% data from training, and this 80% is coming from backside of the training data set, right? And we are building the complete data set here, and on top of it you can apply stuff shuffling, then you apply repeat method, then you choose or create a k-fold validation data sets, right? And then you perform machine learning on top of it. In that way it will give you much more smoother and better experience, okay? And the model can learn very diversified uh, dependencies, okay? So this is how you can manipulate the split API basically. Now next come up one thing just we want to share here is the info thing that in the previous tutorial also we have shared. So if you mention this parameter with info equals to true, you will get all the info loaded for your data set in TFDS, right? And once that is loaded, you can check it. So if I just call info, I'll have a dictionary on dataset info metadata basically with the key value pairs. You can see, and based on the requirement, then I can subside based on the dictionary notation, right? Now the next important API or next important concept here is your TensorFlow record, TF record basically. Okay, so let's say inside the root folder basically, see where is the root folder. Inside the root folder we have this TensorFlow datasets, and we have loaded this MNIST dataset 3.0.0, and inside that you can see there is MNIST train sharding for train dataset TF-record. There is test sharding for test record, and you can see there is a image information. So if you click on this, you can click and verify, okay, the encoding format and shape is present for images, which is 28 cross 28 cross 1, and your encoding format is PNG here. Your feature JSON you can also share and see all the details that you required is available here, right? And dataset info as well, you can see all the dataset info that is present here as well is present here as well, okay? So this is how your TensorFlow dataset decorates or basically structured all the data, okay? So these are the record files, and this thing you have to learn. You, if you have a very good understanding about how TF-record works, then you can definitely structure your pipelines very much well, and you can build your projects with much more confidence, okay? So as we have mentioned, we are just giving this root as the file name. Now let's say tf.data.tfrecord dataset, right? So this is the method for loading the file or TFRecord files. Okay, TFRecord dataset. So if you just copy and paste here, we can definitely see. Okay, so this is the API that you can go and discover more. So tf.data.tfrecord dataset has file names, compression types, buffer size, parallel reads, and name. And you can see basic examples how to use this. A very low level implementation, which probably you will not do until and unless you are writing your own APIs. Okay, so the first thing what we are doing, we are loading the file. Okay, and for the records, we are fetching only the first record and we are trying to print. So this print will not be much more effective, as you can see, as internally we have some numpy values, which is by default it converts it into a hexadecimal uh, decoding format, right? So here I don't think anyone can understand much what this record contains. This is the first record, right? So how to read TF-record dataset or TF-records basically. So first you have to create a feature description. So how you will get the feature description? Definitely from the dataset info, right? So you can see here about the feature description. So we have two features, one is image, one is level, and you can see that it's class of unsigned integer and it's class of integer 64 bit, right, for levels. So this is the feature dictionary that it has provided. So we have created a feature description based on basically it's nothing but a key value pair, and in this key value pair we have pasted the keys taken from here from the metadata information we got from the info. Okay, so image and level, right, these two you can see. And as we know that these are all fixed length, so tf.io.fixed feature. Okay, and the first one we have mentioning the data type as string as to compensate along with this, and the second level we have known that the data type is integer 64, right? And then once your feature set or feature dictionary is ready, then what you have to do, we have to pass this one. Basically we have to pass this one to a parser. So the parser method is available inside Snowflake tf dot sorry inside tensorflow.io. So tf.io.parse single example. This is the method that will take one example. So one example it will take of your TF record, and it will also take the feature description, and based on it, it will return you the parsed value basically. So now you can see, once this is done, you can parse the dataset using the map method. Okay, that's available inside TensorFlow as well. So your raw dataset dot map, and then you parse this function. Parse function we are passing, and this parse function is taking your parse single example this method, and it is using feature description, right? So now it's all clear to how to read a TF record. To read a TF record, you will be requiring a feature description. This feature description, how to get? You will get it from the metadata. And once you have created this feature description, you can use a parser. The parser will be available, will be helping you to decode the feature description and along with the TF record. So once these two are mapped using the map function, you can have the decoded data set basically, right? And once you have the data set decoded, you just use the take function. Okay, and you just print it. So if I run this, right, I can now see better. So previously it was nothing but a TF tensor, right, and some numpy which decoded as this image got decoded as hexadecimal in what digits or whatever, right, characters basically, right? But now in case you can see, right, you have the image which is your training data basically, and in the image as you have mentioned tf.string, right? So the image you have seen here as a hexadecimal characters in string format, okay, which you can use any image reader to read, right, and it will provide you the image. And also you can see here the levels, right, the levels as data type integer 64, okay, and the first level is 2, okay. So this is how you read TF record data, as we have just shared in this what example basically. So split API and TF record, and these two are very important and basic and must to have in your bucket list when you are building TensorFlow machine learning libraries or machine learning pipelines, basically using TFDS, right? So understanding TF records will give you the know about how to efficiently build the pipelines, as well as understanding split API will help you to much more better organize your sampling, your validation dataset, your training dataset, and your testing dataset, right? So that's it for this tutorial. I'll come again with the next tutorial on TensorFlow dataset as well as many TensorFlow's features. So stay tuned. Thank you.